guys, so let's do this. Let's apply what we just learned from the notes, setting up the interval chart. And if you look at this, we are solving this algebraically. Yes, you can solve this graphically, but you will be losing the majority of the marks because you did not answer the question. So let's cheat a little bit first. So because I want to give you guys a rough idea what kind of answers you're looking for, so that as we work out this, solve this algebraically, it makes sense to you. Okay, so let's graph this. So algebraically solve the following inequalities. X squared minus 3x minus 4 is greater than or equal to 0. So basically what you're trying to do is which part of this graph is greater than or equal to 0. And of course, once again, we are talking about this with respect to y. So y is equal to that, which is greater than or equal to 0. So that implies that y, which part of this graph, when y is greater than or equal to 0. So now let's graph this to see what happens first. So this is a graphical approach. So we want y equals to x squared minus 3x minus 4. Okay, and then graph it. So if you want to find out the exact value of the x-intercepts, you go ahead by using second trace, blah, blah, blah. But this time I'm going to eyeball that. So 1, 2, 3, 4. 4 and 0, negative 1 and 0. So if you look at the question again, which part of this graph is greater than or equal to 0? So obviously this part is greater than 0. And this part is greater than 0. We're comparing that with respect to this line when y is equal to 0. This part here is less than 0, but that's not what the question is asking. The question is asking which part of the graph or which parts of the graph is greater than or equal to 0. So here and here. Okay, got it? But now, how do we show this or solve this algebraically? As I said before, I cheat a little bit. I use the graphical approach. So now, how do we solve this or show the work? So we know our answer is or are when x is greater than or equal to 4. 4 here is greater than 0, equal to 0. Anything here, anything greater than or equal to 4 would work. Anything less than or equal to negative 1 here, starting from here, would work. Now, how do we show our work? Let's sketch this. So draw a number line. We know that our two x-intercepts are 4 and negative 1. And our graphs look something like this. So 1 here, negative 4 here. So I'm not going to do a complete accurate drawing. Just give you a rough idea what the graphs look like. Something like that. And our answers are here. Here. Y is greater than or equal to 0. Okay, here and here, not here. Same question again. How do I show this algebraically? Don't just say, oh, based on the graph, this and this, blah, blah, blah. Nope. You will be getting less than 50% of the mark. So what do we do? Have a look at the notes on the previous page. Pause for a second, have a quick look. Okay, so if you look at your notes, the first on the previous page or previous slide, the first thing we talked about was the critical numbers. So those are the numbers that would make the function equal to 0, or i.e. they are the x-intercepts. Okay, so in this case, let's do this here. We want to factor this so that we know where the x-intercepts are. I know you say, Chen, didn't we figure out this? Yes, remember, we cheat a little bit by figuring out this graphically. So assume we have not done any of this work at all. Okay, so we want to factor this, okay, so that we can find out the x-intercepts or the zeros. So in this case, that's easy. You have a 1 as a coefficient in front of x squared. So we can do this, the math 10C stuff. Okay. So find two numbers that multiply to -4 and add to -3. So they are -4 and +1, and we keep the sign there. Same inequality sign, greater than or equal to 0. Greater than or equal to 0. Okay, what does that tell you? That means our critical numbers are, because we know something will be happening around the x-intercepts. So our critical numbers are, well, I'm going to skip a step. What will make this whole thing equal to 0? Set this equal to 0. X minus 4 equal to 0, and that means x is 4. 4 minus 4 gives you 0. Set this equal to 0 as well. X plus 1 equal to 0, and that means x is -1. If you plug in -1 here, that would make this whole factor equal to 0. So from this, we figured out that something would be happening around 4 and -1. Alright, now let's set up the interval chart. Interval chart. Okay. So what we need to do is put the factors, these and this, as a heading of each column. Here, 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 so on and so forth. So it doesn't matter which one you put first, the order doesn't matter. So x minus 4. X minus 4 as one factor. Another factor in this case is x plus 1. Okay, we will leave this column blank for now. You'll see in a second what's going on. Next, we are going to put the interval here. If you look at this, I hope you can see that there are 3 different sections. One section here, another section here, another section here. We want to see, or we want to show algebraically what happens here, what happens here, what happens here. So that's why we have 3 sections. So it doesn't matter which one you look at. Okay, so also, if you just take out this graph, it would help us to visualize what's going on. So one section, and a section, and a section. Ignore this. So 1, 2, 3. There are 3 sections here. So one section is anywhere less than or equal to 1. X is less than or equal to -1. We try to keep the sign because we have the equal component in our question, so therefore we keep the equal component there. If there's no equal part here, then take out the equal part. Okay, next, second region here. So this is the region when x is somewhere between 4 and -1. This is what we will say in plain English. So how do you write that out in math? So x would be less than or equal to 4. So this part is less than that, but then this part at the same time is greater than this. So greater than or equal to -1. One more region. Okay, so this region is greater than or equals to 4. Again, the equal part, so greater than 4. X is greater than 4. There's an equal component. Keep the equal component. Because in this case, our value can be equal to 0. Equal to 0 when it is equal to 4. That's why with the equal sign. Or equal to 0 when it is negative 1. That's why we have the equal component here. Alright? And the last thing we need to do to set up this interval chart is to find some test points. So test point. So pick a random number in each region. So if you look at this one here, x is less than or equal to negative 1, so pick any numbers that would meet this condition. Try not to pick a number that lies exactly here. So don't pick negative 1 because you are going to make your life miserable. Okay, those are a little bit iffy regions, so you can pick anything you want. Anything less than negative 1 would work. I shouldn't say would work, but like would be a good number to use. So you can pick negative 2. If you think your life is not miserable enough, pick negative a million. Okay, but I'll just pick something easy. Can you pick negative 1.1? Absolutely, but why do you want to do this? So let's pick, in this case, negative 2. Negative 2 is less than negative 1, so that's good. Negative 2 is here, so that satisfies the condition. Now let's plug in negative 2 here. Okay, if you plug in negative 2, negative 2 minus 4 gives you negative 6. Okay, so if you take this test point, put that number in that factor, so in this case, we are not going to write down negative 6. We just need to know whether it's going to be positive or negative. You will see in a second why this time we are not that accurate, or we don't need to be that accurate. So this will give you a negative number. If you plug in negative 2 here, negative 2 plus 1 gives you negative 1. We don't care about the 1. We just know that if we use the test point, negative 2, this factor would become a negative. Okay, now what do I do with the sign? We can now set up the last column, which is f of x. Or if you want, you can call that y if you don't feel comfortable. So if we plug in this test point, negative 2 here and negative 2 here, we would get a negative number, a negative number. Negative times negative gives you positive. Let's do a couple more. Let's finish this. Next, let's pick a number somewhere between negative 1 and 4. So there's so many numbers you can use. You can use 0, 1, 2, 3, or you can use 3.99, something like that. But why do you want to make your life miserable? So if I were you, I'll pick 0. Nice number. Alright, so if x is 0, plug in 0 here and 0 here and see what kind of sign we are getting. So 0 minus 4 gives you negative 4. That's a negative number. 0 for x. 0 plus 1 gives you 1. That gives you a positive number. Now basically what we are saying is if we plug in 0 here for x, this factor would be negative. This factor would be positive. Negative times positive gives you negative. Okay, you might want to pause for a few seconds and then quickly work this out. Alright, now here, this region, pick something greater than 4. Okay, 4.1 would work, but pick something nice to make life easy for yourself. So I will pick 5, let's say. So plug in 5 for x, because 5 is greater than or equal to 4. So that satisfies the condition. So pick 5 here. So 5 minus 4 gives you 1, which is positive. 5 plus 6, sorry, 5 plus 1 gives you 6. So this is a positive number. Now, if you plug in 5 here for x, 5 here for x, you would get positive number, positive number. Positive times positive gives you, of course, positive. Now, what do I do with this chart here? If you look at this, what are we talking about? We want a y value, or we want a function that is greater than or equal to 0. So that means we are looking for something positive. Now look at this last column. Okay, which region? There are 3, 1, 2, and 3. Which region or regions would give you a positive f of x or positive y values? This region, when x is less than or equal to 1, when x is greater than or equal to 4. Positive for this, positive for this, they're good. Negative for this, nope. We want that to be greater than or equal to 0. So that means our answer is x is less than or equal to negative 1. X is less than or equal to negative 1. And we have a second answer here. X is greater than or equal to 4. X is greater than or equal to 4 as our answers. Now, this is the algebraic part. If you look at the answers that we just figured out algebraically, let's look at this. X is less than or equal to negative 1, right on. Anything less than or equal to negative 1 here is correct. And x is greater than or equal to 4. Anything 4 and above here is also correct. So let's just do this. So our answers include negative 1. So we use a solid dot. Anything less than or equal to 1 would work. So here, anything here. Okay. And our second part of the answer, anything 4 and above. Anything 4 and above, so including 4 as well. Anything here would work. Now, bingo. So for the next few questions, I'm not going to draw the graph as explicitly as this, but you can definitely use your graphing calculator to help you visualize what's going on. Good. So having fun, even though I'm not physically there with you, I'm sure you are having so much fun. So let's do more. Next question. This. So pause for a few seconds, try to think about what's going on. And if you think using the graphing calculator to cheat a little bit to help you visualize the answer, you go ahead. But even if not, we can still work this out algebraically. So if you look at this, we have negative x squared plus plus 12 less than 0. Alright, so of course we are talking about with respect to y. Wrong color. So y equals to this, which is less than 0. So that implies y is less than 0. So we want to look at which part of this graph when y is less than 0. And we want to express that region with respect to x. So we want to indicate that for this part of x from here to here, y would be less than 0. So in this case, that means we are looking for something negative in the negative region. Alright? So first thing is to of course, find the critical numbers. If you look at this, the coefficient in front of x squared is not 1, it's -1. So what do? We factor out the -1. So we divide everything by -1. So take out the negative first. Okay, divide this by -1, that gives you x squared. Divide this by -1, that gives you negative x. Divide this by -1, that gives you -12. And we want to find out which part or parts of this graph would be less than 0, i.e. when y is negative. So now we can do the factoring, math fancy stuff. This and this less than 0. And this is simple stuff. Find two numbers that multiply to -12 and add to -1. So, and they are -4 and +3. This time I'm not going to graph it at all. I mean, I'm not going to show you what it looks like on your graphing calculator. If you want, you can cheat a little bit. So, doesn't matter what the graph look like. You may have a graph like this, or you may have a graph like this. Doesn't matter. We know one thing for sure. Something would be happening around here when x is 4. So, before that, let's quickly write down the critical numbers. Critical numbers. And they are, in this case, x equals to, what would make this factor equal to 0 when x is 4. What about this one here? When x is -3. So we know for sure something would be happening around 4 and -3, either going from positive to negative or negative to positive. Doesn't matter. Okay, so let's erase this. So let's draw a number line here. We know something would be happening around 4 and then -3. Okay, it's going from positive to negative, negative to positive. We'll figure that out. So now we have figured out the critical numbers. Let's set up the interval chart. So again, pause a few seconds, quickly set up the interval chart. Do as much as you can. Okay, the interval chart. And then we put down the factors. Alright. So factor here is x, oops, nope, x minus 4. Leave a column blank here. X minus 4, another factor, x plus 3. I know I need to have one more column here for f of x, or for y, whatever you call. F of x is fine. If you want to call that y, that's absolutely fine. Okay, now what am I supposed to put here? This negative. I know you say or argue with me saying that Chang is just a negative sign. Yes, you're correct, but then actually that means it is -1. So you have a negative component here. Even though it's a 1 and it's just a negative, but as you all know, it can flip the sign. It can change everything. So you need to keep this negative into account. And if this still doesn't make sense to you, once we work on the signs here, it would be more obvious. So now let's set up the heading for each region. So we have one region here that we need to look at, another region, and a region. So once again, we have 1, 2, and 3 regions. So this time, it is some, for this part here, for this region, it is anything less than -3. So x less than -3. And because in our original question, we um, we we have less than sign, so we do not include 0. Okay, so therefore we don't have the equal component here. Next region would be somewhere between -3 and 4. So less than 4, x is less than 4, but greater than -3. Greater than -3. Again, no equal component here. Okay, last but not the least, anything greater than 4 here. So x is greater than 4. And of course, you know we are going to use some test numbers, test point, test point. All right. So pause for a few seconds, quickly pick up a few points. For anything less than -3, let me pick -4. Okay. So now let's plug this in. When x is equal to -4, -4 minus 4 gives you -8. So that will give this part negative, or make this factor negative. Plug in -4 for x here. -4 plus 3 gives you -1. So that would make, when you plug in -4 here, this factor would become negative. And if you look at this factor is negative, this factor is negative. Negative times negative gives you positive. But wait a second, there's a negative sign in front, so that would turn the positive to negative. So negative times negative gives you positive. Positive times negative gives you negative. So basically, you can put down negative here, because this negative here, the same one here, would reverse the sign of whatever happens here. Okay, negative times negative gives you positive. Positive times negative gives you negative. Okay, let's keep going. Now pick a number somewhere between 4 and -3. Like, you probably know what I'm going to pick. Let's pick 0. 0 minus 4 gives you -4. That gives you negative. 0 plus 3 gives you 3. That's positive. If you look at these two, negative times positive gives you negative. But then there's a negative to apply to that. So negative times positive gives you positive. So see how the negative sign, even though it's just a sign, it can totally change things. So here, for this region, pick a number greater than 4. So I'm going to pick 5. You can pick anything other than 5, like as long as it is greater than 4. 4.1 is fine, a million is fine. Anyway, so 5 minus 4 gives you 1, so that gives you positive here. 5 plus 3 gives you 8, so that gives you positive here. So if you look at this, the region that would give us a negative value would be here, less than 3, -3. Do I include -3? Nope, because less than, there's no equal component, so we use a open dot. And then another section that will give us a negative y value would be when x is greater than 4. So anything greater than 4, like this, would be the answer. Do I include 4? Nope, because there's no equal component. So once again, we use an open dot. We do not include the number there. So that means anything from 4.01 all the way to positive infinity would be my answer. And also anything less than -3. So from -3.01 all the way to negative infinity, they would be my answer. So x is less than -3 is one of my answers, and also the second part of my answer is x is greater than 4. So there are two answers in this question. So before you check out the rest of this video, you might want to give yourself a few minutes, do as much as you can. All right, so assuming you have done that already, let's quickly finish this here. So this question is negative 2x minus 3 less than or equal to negative x squared. All right, so this question seems to be a bit more tricky. Well, of course, this is our third example. So first thing, hope you know we are going to look at that with respect to y. But before that, if you look at this given part here, it's slightly different from what we had before. If you look at the last two examples we did, we always have 0 on one side. So in this case, do we have 0? Nope. So what do? Move this. Doesn't matter. You can move all this to one side, like move all this to the right hand side, or move this to the left hand side. If I were you, I would move this to the left hand side. Why? Because in that case, if you move this to the left hand side, that will give you a positive x squared. Okay, so let's quickly do this. Plus x squared plus x squared. So left hand side, I have x squared minus 2x minus 3 is less than or equal to 0. And I'm talking about this. So that means I'm looking for the region of x in which y is less than or equal to 0. So that means a negative. Alright, so first step, of course, we need to find the critical numbers. Now we have this, and it is 1. The coefficient is 1 for x squared, so that would be easy for us to do the factoring like this. Still keep the inequality sign. So if you do the factoring, what two numbers multiply to negative 3 and add to negative 2, that would be negative 3 and positive 1. And that means our critical numbers are 3, that would make this 0, and negative 1, that would make this equal to 0. So x is 3 and x is negative 1. Okay, so let's do a quick sketch to help us visualize what's going on. Again, you can cheat a little bit by using your graphing calculator. So the number line here, I know something would be happening around 3 and negative 1. So 3 here, we don't have a joy in scale. Negative 1. Maybe the graph going from positive to negative or the other way around. We'll figure that out. So let's set up the interval chart. So the interval chart, and then put down the factors. So my factors are x minus 3, x plus 1, and then of course the final result, the combined result, the final product, you can put down f of x, or if you want, you can put down y, doesn't matter. Okay, and then we obviously have 3 regions to look at, 1, 2, and 3. So first region here, this region, anything less than negative 1, including negative 1, because we have the equal sign. So anything less than negative 1, including negative 1. And then this region, anything between 3 and negative 1. So x is less than 3, greater than negative 1, and again, inclusive. So equal, equal. Last but not the least, this region here, anything greater than 3. Anything greater than 3, including 3, because of the equal sign. Okay, and then of course, we would pick some test point. Sorry, it's a little bit messy, but we'll just make some space. Okay, so test point. So anything less than or equal to -1, pick -2. Okay, so plug in -2 for x here. That will give you a negative number. Plug in -2 here for x. This factor would give you a negative number. Okay, yeah, I'll explain this in full detail one last time. -2 for x, -2 minus 3 gives you -5. So this factor would become negative. Plug in -2 for x here. -2 plus 1 gives you -1. So this factor would become negative. Now, if this factor is negative and this factor is negative, negative times negative gives you positive. Okay, next, pick a number between -1 and 3. I know you will pick 0. Okay, plug in 0 for x here. This factor would become a negative number. Plug in 0 here for x. The factor would become positive. And then negative times positive gives you negative. Okay, so pick anything greater than or equal to 3. So let's pick 4. So plug in 4 here. That will make this factor positive. Plug in 4 here. That will make this factor positive. And then this factor times this factor, positive times positive gives you positive. And which column are we focusing on now? This column. Okay, now what kind of sign are we looking for? We are talking about less than or equal to 0. So that means we are looking for a negative number. Positive, nope. Positive, nope. Negative, yes. So that means this time we only have one answer, which is this. So x is somewhere between 3 and -1. So let's jot this down. Look at this. We are doing ourselves a big favor by writing everything out as explicitly as we could. So my answer is x is somewhere, or I should say this way, x is less than or equal to 3 and greater than or equals to -1. So what does it look like graphically? So anywhere between 3 and 1. So that means anywhere between 3 and -1. 3 and -1, including 3 and including -1. So that means we put a solid dot here, because the numerical number could also be 3. The numerical number could also be 1. Okay, because if you plug in 3 here, this whole expression equal to 0. Is 0 okay? Of course, yeah, equals. If you plug in -1 into this expression, either here or here, this whole thing would be equal to 0. Is 0 okay? Of course. Okay, so that's why we need to put a solid dot and use the equal sign. Okay, I'm not going to do the last one. I'll let you have the fun. So you might want to quickly copy down this question here. And the answers are already on D12 in the PDF notes. Alright, and then the last thing would be this. Okay, check all this out. Have fun doing these problems.